Our goal right now is to understand, demystify, and get you comfortable with this notation right here. This is called summation notation, also sometimes referred to as sigma notation, because this letter that you see right here that looks very much like an E is actually a Greek letter sigma. Let's just run through it and tell you what's going on and see what this means and show you that it's not that bad at all. So what we have down here is a letter. This letter we're going to call the index, and it's going to have what we refer to as a lower limit or a starting value and an upper limit or an ending value. So I would say this is a sum with an index of n that goes from n equals 2 up through n equals 5. And here's how it works. You simply start with this number at the bottom, the 2, and then you go up by 1 until you get to the number at the top. So you start with a list of n's. So I'll put here, these are n equals 2, n equals 3, n equals 4, n equals 5. Start at this one, end at this one. That I know you can handle. The next part of it is, one at a time, you take these different n values and you put them in here. There's always some expression inside of a summation notation. It's very often in parentheses just to show you that it's grouped together. And it goes like this. It says, all right, put a 2 where you see the n's. So 3 times 2 squared minus 2. Well, remember your order of operations. Exponents first, so 2 squared is 4. Then multiply, 4 times 3 is 12. 12 minus 2 is 10. There it is. Now, do the same thing with n equals 3. So put a 3 in, so 3 times 3 squared minus 3. So everywhere you saw the letter n, you're now putting the number 3. Well, 3 squared is 9. 9 times 3 is 27. 27 minus 3 is 24. And we're just going to do this 2 more times. Next with the 4. So I like to start just by putting empty parentheses wherever you see the variable there, and then replace those empty parentheses with the next number in your list. 4 squared, that's 16. 16 times 3 is 48. 48 minus 4 is 44. And then lastly, do the same thing with the 5. So this is going to be 75 minus 5, which is 70. So this has told me so far, where you see an n, start by putting in a 2, and then put in a 3, a 4, and a 5. Stop once you get to 5. That's the last one that will count. I now have this list of 4 numbers. For n equals 2, 3, 4, and 5, that's 4 numbers. So 10, 24, 44, and 70. Awesome. The last part is this sigma means you're going to add these numbers up. So 10 plus 24 is 34. 34 plus 44 is 78. And then 78 plus 70 is 148. So the way that we would then say this is the summation from n equals 2 to 5 of 3n squared minus n is 148. So I need you to promise me you are not going to let the fanciness of this notation intimidate you. Let's break it down just to make sure you understand all the appropriate terminology. So here we go. This large Greek letter, this is a capital Greek sigma, an equivalent to a Greek S, which stands for sum, because we're adding things up. Now the variable down here, this is referred to as the index. It can be any letter you want. Very often it'll be an I or an N, sometimes a K, an A T. Again, you can use any variable you like. So just pay attention to what's down here. That'll let you know what variable is your index overall. Because sometimes there might be more than one letter over here. And then this is your lower limit of your index. It's also, it's your starting value, right? That's where you start. Very often, this will start at 0 or 1. Very often, this will start at 0 or 1. I'm just going to, I don't know, what's a good way to put that? Just another set of parentheses. 0 or 1 often. However, it doesn't have to be. You can have that be any number you want to start with, as long as it is a whole number. And now up to the top, this is your upper limit or your stopping point. And then what's in the red box here, that's just an expression that will change from example to example, from problem to problem, from case to case. All you do, start with I equals 1, put 1 in for the i's, then put 2 in for the i's, then put 3 in for the i's, all the way up until I equals 30, and then add those numbers all together. Your first thought may be, why? Why take something as simple as adding numbers together and make it look this complicated? The answer is, I need you to trust me a little bit. It makes things easier in the long run. It makes things much easier for more complicated situations. Okay, first part of your toolkit. Take a moment to fill this out. Over here off to the side, after you've gone through some practice, include in there what you think is most helpful. I will leave this portion completely up to you.